Hello, everyone. It's my honor to present like Dr. Maryam. She's an AI and data science lead at TMNL, and she'll talk about a very hot and cool topic that's deepfake. Thank you, Doctor.
Thank you. Thanks a lot. Good afternoon, everyone, and welcome to my talk. As mentioned, my name is Miradi. I am an AI and data science lead at TMNL. And my background is in AI. I have a PhD in AI deep learning. And for quite a number of years, I have applied AI to different industries. But the last 5 years, I was working in detecting financial crime and anti-money laundering. And this is where I researched deepfake and noticed that deepfakes can be used to steal identity and commit fraud. Today, I'm going to give you guys an impression of deepfake, hopefully, and we will start actually by definition of the deepfakes. What are actually deepfakes? The term deepfakes consists of two terms, deep learning and fake. And simply put, is actually synthetic data or synthetic medias where a person's face has been swapped with another one. Of course, we can do this with different things like also Photoshop, but AI and machine learning can improve, have really strong deepfakes. And when you have a deepfake, you can either use it for positive side, like entertaining, or to deceive and to commit fraud, as I said. Today, we are going to explore together the following parts. First, we go how is deepfakes are made. This is where I explain it a little bit on software level. Hopefully, after this, you will go to pick up the GitHub, just play around with the deepfake, and just make your own deepfake. In the second part, made deepfakes, can we improve it? Can we make it better, beautiful, with more generative AIs? And I hope to give you an impression of what are generative AI, generative adversarial networks. And my aim is that after that part that you go and write your own Python code on the GANs, but more of understanding of what's happening under the hood. So a bit of the science and intuition behind it as well. Then we go to the good and the bad. This is applications. What kind of stuff can we do with it? What kind of effect has it? And when I started this, I told actually it can be used completely misused for some purposes. And the last one is, okay, we have developed the deepfake. They are made with AI. Can we use AI or other techniques to recognize them as well? Let's start with making a deepfake. This is a simple deepfake if you have the original one, and you have a face of 3 different people, and you want to swap with it. So as you can see, the characteristics, the facial characteristic of these people has been kind of swapped with each other. And it looks pretty natural. How can we do that and imitate that? Actually, there is software, and they call themselves leading open source software at deepfake. I let it to you guys to judge that. But it is, and they have this paper of 2021, and all of the details are there. But you need some materials. And where do we have materials? Most of the time from celebrities. So let's take Robert Downey Jr., Elon Musk, and we want to swap their faces. The deep learning technique that they use is autoencoder. Probably most of you guys have heard of autoencoder, but if you haven't, it consists of 2 neural networks. One of them is an encoder. Just pick up the information of your input, features, picture, whatever that you have as an input, compress it to a latent space, and then decompress it back, reconstruct it back to its originals. And what kind of application can we think of? Denoising a picture, so just making it reconstruct it back. But you can also use that for anomaly detection, because when you compress things and decompress it back, what will be completely removed? The anomalies. So this is actually where the autoencoder has different applications, but let's get back to our making deepfakes. For making deepfakes, you need a picture. So Elon Musk, we need a picture, we encode it, get the base facial characteristic of Elon Musk, and when we use a decoder, it will get back to its original. So far, so good. But if we have two people or more people, what this autoencoder does is that it will just use one encoder for all of the pictures, but then each of the people will have their own decoders. And if we want to make a deepfake, very small trick is that we use the encoder for the original person, but then we swap actually the decoder, and we can then kind of combine the faces. As every project in AI and data science, you cannot go ahead and train the model like just from the start. You need some steps, and most of the time, it's a lot of pre-processing. So putting it like very fast and like in a good flow is that you need about 10 minutes of video of both of them. Then we'll start to extract images. And the frames should be about 600 to 2,000 for this specific software. And then when you have them, you want actually to, each of the frames of the heads, you want to actually have like a kind of outlined mask of their face, because you want to replace that. And how better that mask has been defined, how better you can replace actually the faces together. Let me, let's go for just a bit here, is that then you can use autoencoder and just go the way that I explained it. If the faces are too different, if, for example, my face has a shape and somebody has completely different shape, then we use a little bit of image processing. We use morphing to just like kind of bring the two faces together. Again, the pre-processing I was talking about. And merging means we apply our model to both of them to do the swap. And after that, you still can do post-processing for the eye color, face, like the skin color, and those kind of stuff. Let me show it a little bit visually. Okay, extract the faces. Like, very important from the faces is that every movement, like the way that your face is moving, you wouldn't notice, but actually is really different than another person. So it needs to capture. So if the video does not compare, like it's too quiet, then it will not be a good video. So 10 minutes of video means 10 minutes of video you're really moving around in that video. Then we go and extract and identify the mask the way I was explaining it. Maybe also need a little bit of more manually helping actually the neural network here. Then we will follow actually the heads or the mask in the faces, and now we can start to train and merge that. So if we let the software to go for 23 hours, as you can see in the last column, nothing that much happened. If the original ones, like each of the faces, we reconstruct them, they look okay. But when you combine, we still see Robert Downey Jr. So let it a little bit like go for about 50 hours. And that's where we start to see actually the two faces in the last column start to get kind of combined. So this is the kind of the results after 50 hours. Of course, you can let the software, it depends on how much of patience you have, for 2 weeks or so. And that's where it gets better and better. Let me see if the GIF is working. Yeah, it's working. So it is actually, as you can see, if you have seen Elon Musk, he moves his whole body the whole time to the front and back. And this is actually Elon Musk in his original thing. But the face that is there is the face of Robert Downey Jr. So if you want to have fun, just combine actually the people that are so different from each other. And you can see that. And to do so, it's good to just visit this GitHub. I really like it. Then you can go and look at the Python, all of the models, and it's like API programming. So you just really see what's happening there and what kind of options they are using. So it's a very cool one to try. Okay, we built that, but you guys saw it wasn't that impressive. It looked nice, but you could say this is like hacky, sketchy. No, it's not that good. Although you can improve it with more number of hours, it's still not so good. How can we improve it is with generative adversarial networks. I promise you guys to just have like a deep dive here on generative adversarial networks and what they are. On a very conceptual level, it's like, if you again have never worked with GANs, is that they are consists of two parts. Again, a little bit like autoencoder. It's like have two things, the generator and the discriminator. And the generator is this forger, it will create arts, wants to create something. And the discriminator is the detective one, the one that actually wants to say, that's not good enough. This is definitely a fake. So this is on a very high level. For us data scientists, let's go a little bit looking at the deeper level, and that is that where we have for generator noise. So Gaussian distributed noise will be fed to generator. I will actually create a fake image. And then our discriminator, which has the real labels, the real pictures, will put it together. I will look, I will say, is this actually fake or real? And because there are two neural networks back to back, we can use that loss function, the backpropagation for both of them. And backpropagate from discriminator through the whole process, that loss function, and improve both of them. So it's not that our detective is better or our forger is better. Both of them get better at the same time. It is like they are kind of playing this min-max game. And in that game, basically, it's like the loss function of the two are combined. Let me explain it with the paper from Goodfellow, is actually the creator of GANs. And this is from 2014. If you like it, you can just go deep dive. Do a deep dive in there. And this is actually the training loss. Don't worry, I will explain it. It's a little bit of formula there. But it is actually where the generator wants to create a very good image, and the discriminator wants actually to find actually if this is generated or real. And this is where we see that we minimize actually the loss for generator and maximize it for the discriminator. We just show it on the picture a little bit better, is that we have that formula, we have the both of them, so if we split both of them, you can see that which part of, the noise is just going, so the noise Z is going through the generator look at the G of Z, and then D of G of Z becomes actually, so it's just not that difficult looking at the formula or the loss function. And for a discriminator, it's just the function itself, like the picture itself, and then we get actually both of them. Bear with me, we are almost there. And this is like the whole algorithm. So what we do is that we need to actually do this like play, but freezing one and then going to another one. So the first thing that we do is we freeze our generator. Whatever it is, we just don't care about. It's probably bad, but we don't care about it. We start to just give the images, completely randomly chosen sample, to the generator, to the discriminator, and it will learn actually what's real versus what's fake. And then when the discriminator become good, we kind of freeze the weight, and then we will go to generator, give them some completely different sample of noises, and it will start actually use the discriminator to just kind of becoming better and better. So this is, in a nutshell, the generative adversarial network. And this is the pictures that they are making. So basically, they start with something which is like, it makes absolutely no sense, and it looks super beautiful. As you can see, her skin, her hair, everything looks completely natural, but this comes from the website This Person Does Not Exist, which is a website created by NVIDIA, and every time you refresh, you get another person generated by the website, completely generated by Generative Adversarial Network. You may ask, like, what is the reason that actually the first pictures are so noisy and little, and what's then after that happening when you have like a very good picture? Simply put, is that we start with the progressive growing, means we start with really, really badly pictures, and then we improve it. So it's just like almost pixels what we are doing, and if the neural network gets better in that, then we go to, because otherwise it would not converge. Can you converge from nothing to a very perfect picture? Probably not. So this is also progressive growing, which is combined with that whole formula that I explained to you guys, which is very simply two neural network kind of competing with each other, then using it with lower to very upper layers, and then you get actually good results. I would also suggest to go there and just take a look at this website as well. There are a lot of actually variation of GANs, and I'm not going to like go one by one for each of them, but one of them is like when you just give a text, this is a bird, and it's having there's like a yellow thing and a black beak, and then we just like go and do it, and that's stack GANs. You can also even create like from a Monet to a picture. It's like from the very cool stuff. Any kind of art can be actually changed to a picture, but you even can just like be an architecture, just draw some things. I will give you the real building for showing to your customers. But how can we make deepfakes is with this one. And this is style GANs. A style GANs is basically what we have just talking about, like the growing and everything, but it just creates this conditioning. As you can see, it's a condition of all of these people, their hair, eyes, and everything will be mapped, and it will be combined, and then you can get actually all of these together to something of whatever deepfake that you want. And the reason that it can do, just showing a very simple example, if you want to give some condition, and we want to say it's man or woman, and you want to have like a facial hair or not a facial hair, probably when you have woman, you do not have a beard that much, probably. So then you will have like this empty part actually in the distribution of the Gaussian distribution. But we make everything from that Gaussian distribution. If you have a hole there, then you have trouble in your convergence or building anything. And that's where the style GANs just use mapping to just improve that so that whatever that you are, and I'm just coming with two things, but we maybe can give them like 10 different things about the skin color and the eye color and those kind of stuff. We'll combine them together with something which is like a mapping, and will then give us the better mapping and the better convergence. Still, I want you guys to just remember that base, and on top of that base is just things like kind of stacking up to get that. This is the part that you can go and experiment with the style GANs. And it's, I think, Archive Insights has, in a Google Colab, a style GANs. And you can just go one by one, look at the intuition. You can go look at it has all of the notebooks and everything. I'm building a deepfake. I think I don't need to even explain this. It's the same. You go from data collection, training of the GANs, that go fine-tuning, and at the end it becomes face alignment and mapping, and we swap. And that's the reason that we get actually quality, start to get from bad quality to the nice one. And this is where probably you guys have seen, this is a deepfake of Morgan Freeman, which is definitely not Morgan Freeman. This is just completely generated by the company Deep Network, I think, and it has been the voice and everything has been with the guy actually next. And you can see that he, at the end of the video, he's just kind of showing that it is him talking and not Morgan Freeman. Okay. Now we built our deepfakes. What are the good applications that we can have there? As you guys can imagine, we can use it for satire and humor, education, for entertainment, for film industry, but also make things accessible, make things nice. I don't want to show you the video of a lot of celebrities, but I show you one thing that is really, it was like kind of impressive to me. And this is the video of David Beckham talking about ending malaria, which is like a very deadly disease, but talking in 9 languages. What's actually so subtle about that? He starts with his beautiful British English, but then he will change to Spanish and all of these languages. But then his face, his expression, the way that he talks Arabic or Chinese is actually all that country. And that's really important, so different than when you are talking actually, when you're making a deepfake, which is like having a positive effect. And as I explained, this is like probably now for you guys completely understandable is that your face mask should be, like from David Beckham, should be replaced by all of the people that are speaking those 9 languages. And for the bad, we basically have, the problem is that it's just undermining. What's the effect? Undermining our trust. It's just manipulating the public opinion. It's disinformation. And the problem with that is that we do not know anymore how to trust and what to trust anymore. As well, for example, the United States Congress says now is the line between the fact and the fiction is so blurry. Because everything that is also real, we think, is this real? Like really real? And that's actually the problem. When we had, like was, I think 3 months, the war between Zelensky, between Russia and Ukraine, we saw this deepfake video from Zelensky, which is say, hey guys, just lay down your weapons and the war is over and I want to leave, so you guys should leave as well, which is pretty convincing, I would say, at that moment when everybody's like underground. It didn't look like the best deepfake ever, but it was still really effective to just create so much of chaos and on a very high level. So that's actually the deep effect of deepfake. And we do not need even to have like this material. Do you remember I said that we need like 10 minutes? No, not anymore. Because like papers like this one, the force order motion, is that we just use one picture and it's pre-trained on anybody else, like all of the humans on Earth. And it's just, also take a look at the paper and the GitHub, this is also a very nice one, is that you just can give your own picture or picture of anybody else, use your own webcam, and in a few minutes you will have a deep fake when you are talking online on a Zoom or a Teams talk. So you just can actually do all of these movements. And the scary is that it will predict like the mask, and it can just put it in every lighting. So not even the lighting is a matter, but like, okay, it looks like different in that lighting. And after that, we even have animation. If you guys probably, anybody in gaming, is anybody in gaming? They will probably know the Unreal Engine, which is like one of the people, like one of the best companies there. And they are basically creating almost real films that you can, so even do not need to use any of that. I think this part for you guys is completely understandable, that if we want to speculate on the future of deepfake, of course the entertainment and stuff is really good, but the problem is the privacy when you just, or the security or the chaos that we have. So the red area is where we really want to actually have more emphasis on it. Can we recognize deepfakes? We have a bunch of things that is like in a forensics analysis. It's like facial inconsistency. You can see it, and audio inconsistencies, stuff that are pretty good with good analysis. You can find it, or metadata. So when has been recorded, the farm has been recorded, and those kind of stuff. But we can also use AI. So if we look at the forensic, we have these professor from Berkeley, the UC Berkeley, and he has also really good stuff on follow him. He will always like post things on deepfake if you like deepfake, and he will show. And he's like this. He's playing this mouse and cat game. Every time that something appears with his whole team from Berkeley, he tries actually to solve it. But the problem is that you always one step behind the criminals. But I personally like this one. You know, the people that are actually having their heart, like the heart patients, that having their heart actually measured, they never do it anymore with that nasty things that are on their skin. They do it with the app, which look at their heart pumping to their face, and the color of the face start to get all of these flushes, the red flushes that comes. It's like very micro changes in the color, and will then measure your heart rate. But the same thing can be used for a human being and a deepfake, because a human being will have blood flushing to their face, but a deepfake not. So it's really easy to use that next to deep neural network, and then actually have pretty good results. This is, has been like productionized by Intel, and they say 96%. And BBC was looking at it, so the 96% was a little bit, as a third party, it was a little bit lower, but it's one of the best deepfake detectors out there. I'm not going to bother you guys with all of the companies, because it's just like kind of a lot of black boxes there that you can take a look at. One thing that has come to mind is the blockchain. They use technology of blockchain to just have actually the data secure, so it's not deepfaked actually there. So we are coming to the end of presentation. I showed you guys how the deepfakes are made. Can we improve them a little bit? We could improve them a little bit with the GANs, and hopefully you got also an impression of how GANs are the good and the bad of deepfakes. And finally, can we recognize them? Yeah, with PPG, we can make some steps. Thank you so much.